Hello, everybody, and welcome to yet another week of virtual math analysis. I hope everybody's doing okay and that, in spite of everything, you had a decent Easter. So, this week we are going to be continuing in with more stuff on section 3 of chapter 0. If you didn't do the things from last week, from 03 part A, you want to make sure that you do go through and look at that video and do some of the problems there to make sure you know what's up with that, because the quiz you're doing this week will actually involve both last week and this week's material. What we're going to talk about this week actually could take you all the way back to about first grade, because we are going to be doing some work with fractions. I'm going to start by reviewing a couple of problems that are more like third or fourth grade than first, but I want you to think about what do you have to do to solve a problem like 2/3 plus 1/4. So think about that for just a second, and then we'll talk about how to do that and figure out what it has to do with where we're going from here. So remember, when you add fractions, what you've got to do is find a common denominator. And if I have things like thirds and fourths, the common denominator ends up being 12. You can always find a common denominator just by multiplying the numbers on the bottom. 3 times 4 gives you 12. Sometimes that's not the least common denominator, but it will always work. So I rewrite everything in terms of 12. Basically, I figure out what's missing to get twelfths out of thirds. I got to multiply by 4, and whatever I do to the bottom, I've got to do to the top. In order to take 1/4 and make it twelfths, I multiply by 3/3. I end up with 8/12 plus 3/12. And the important thing when you're adding fractions is you add the stuff on top, but then you leave the bottom alone. And that's why my final answer here is going to be 11/12. It's not 11/24, it's just 11/12 for the final answer. Now take a minute and see if you can do this subtraction problem. 5/16 minus 1/8. So the easiest common denominator to work with this time is going to be 16. That's because 8 times 2 gives me 16. And if I write things in terms of sixteenths, I'd have 5/16 minus 2/16. That just gives me 3/16. You could take 16 times 8 and get 128 and rewrite everything in that term. Then you're going to have an answer that you have to reduce at the end. It's okay to do that, though, and you should end up getting 3/16 either way for the final answer. Now, you, of course, could have done both of those problems with a calculator and gotten an answer way quicker than you could have with common denominators. But the problem is that we also encounter fractions that have variables in them, what we call algebraic fractions. And those you can't do on a calculator, which is why we need to use those same rules to come up with answers for them. So I'm going to look at this problem. X plus 2 over x minus 1 plus x over x plus 4. A lot of times people will look at a problem like this and just say, forget it, I don't want to do this, it's a pain in the butt. But really, it's the same as the very first problem that we did. It's just adding two fractions. Now, unfortunately, those fractions do have both variables and numbers in them, but the process is still exactly the same. I'm going to find a common denominator, I'm going to rewrite stuff with that common denominator, and then we're going to add up to find out what the answer is. So first off, we want to look at these fractions, x plus 2 over x minus 1, plus x over x plus 4, and rewrite them using a common denominator. Now, when in doubt, that common denominator is just the bottom of the first fraction times the bottom of the second fraction, and that's exactly what it's going to be here, is just x minus 1 times x plus 4. So when you rewrite with a common denominator, what you've got to do is multiply each fraction by what's missing on the bottom. So in the first fraction, I multiplied both top and bottom by x plus 4. And in the second fraction, what was missing is x minus 1, so I multiplied the numerator and the denominator by x minus 1. Doesn't matter what order you write it in, but you've got to make sure that you've multiplied both top and bottom by whatever's missing in that fraction. Next, we've got to distribute everything. That's what in Algebra 1 you called FOIL. I'd look at x plus 2 times x plus 4, and I multiply x times 4, 2 times x, 2 times 4, combine the like terms in the middle, and I did get x squared plus 6x plus 8. I do the same thing in every part of this, and you can see what we've got once we distribute everything out. Now we have to actually do the addition, and that basically boils down to combining like terms. Remember, when you add fractions, you just add up the stuff that's on top and you leave the bottom alone. That's why I'm getting 2x squared, 6 minus 1 is plus 5x, and then there's nothing to put the 8 together with, so plus 8. 2x squared plus 5x plus 8, all over x squared plus 3x minus 4. So again, my original problem is shown there, and we've got the final answer. All I did was find a common denominator, distribute everything out, and then add up the like terms on top. So I'm going to leave this up here for a moment. You might want to pause the video and see if you can actually come up with an answer for 2x plus 1 over x minus 1 plus x plus 4 over x plus 2. I'll pause a few seconds, but you might want to pause it for a while until you get an answer. So here the common denominator is going to be x minus 1 times x plus 2, and I need to multiply both fractions by what's missing on the bottom. Something you might have noticed both on this problem and the one before it is I always put parentheses around each of those terms. Part of that is it just makes it easier to do the multiplying when I get to the next step. I do distribute everything out, and that means I get 2x squared plus 5x plus 2 all over x squared plus x minus 1, and then plus x squared plus 3x minus 4 all over x squared plus x minus 1. Finally, we add up the stuff on top, so 2x squared plus x squared gives me 3x squared. 5 and 3 makes plus 8x, and 2 minus 4 is minus 2. So 3x squared plus 8x minus 2 all over x squared plus x minus 1. The bottom, again, doesn't change at all. And here's another problem that I want you to take a look at. 4x plus 3 over x minus 5 minus x minus 7 over x plus 2. The important thing about this problem is it does say minus in the middle. It's a subtraction problem. And again, if you want to pause the video and then compare answers here in a second, this might be a good place to do that. So just like before, the first step is going to be to find the common denominator, and here that's x minus 5 times x plus 2. I multiply by what's missing in each of those fractions. And then I distribute everything out. Now, something you'll notice if you look carefully at this is I put the second fraction, I put the top of that in parentheses. And that's because I've got to be careful in the next step that what I'm doing is subtracting rather than adding. So when I get to combining like terms, I'm going to take 4x squared minus x squared, 11x minus 2x, and 6 minus negative 35. And that does give me my final answer of 3x squared plus 9x plus 41 all over x squared minus 3x minus 10. So next I want to look at a couple more review problems just to remind you of what happens when we're working with numbers as opposed to variables in problems. These two are multiplication problems, and the point of those problems, if you take like 2/3 times 5/7, All you do to get the answer is you multiply across the top and you multiply across the bottom. That's why my answer is 10/21. On the one after that, the problem started as 3/8 times 6/5. And what most people call the first step you do is canceling. I figure out what's going to go into both 8 and 6, and basically I can just divide both of those numbers by 2. Change that problem into 3/4 times 3/5. Now I just multiply across the top and across the bottom, and my final answer is 9/20. If you wanted to, you could have just gone back to the original problem, multiplied everything, and gotten 18/40, and then reduced 18/40 to 9/20. That works too. And I've also got a quick division problem here. We have 5/9 divided by 3/8. Now most people know that when you do division of fractions, you multiply by the reciprocal. The important thing is it's the reciprocal of the second fraction. I turn the second fraction over and then I multiply. So this problem's the same as 5/9 times 8/3. Now I just multiply across the top, multiply across the bottom, and I get 40/27. So we'll get back to what that has to do with algebraic fractions. You might come across a problem like this, which is still just a multiplication problem, but it involves fractions. So the first step you want to do on a problem like this is some canceling. When I look at this problem, I notice that there's a factor of x plus 2, both on the top and on the bottom. Doesn't matter which fraction it's in, if you see a factor that repeats, you can cancel it. I can also cancel out x plus 3 on the top and on the bottom. Now there are some things people sometimes will try to do that's wrong. What you see there is right for canceling this. Sometimes though, I'll see people that, for example, they want to cancel the 8 and the 4 at the end. You can't cancel something that's got a plus next to it unless it's identical with something that's on the top and bottom of both parts. Here it says x plus 8 and then x minus 4. Those are different, and so they just stay. The last step is just multiply everything out. Actually take x plus 8 times x plus 8. That gives you x squared plus 16x plus 64. And then take x minus 7 times x minus 4. You get x squared minus 11x plus 28. And that's my final answer. That's all you do with this. And we're going to look at one more problem in our examples today, and this is a division problem. It's a division problem that does involve algebraic fractions. We have x plus 1 over x plus 2 divided by x plus 3 over x minus 4. So we're dividing some fractions, and you want to think, what would we have to do with that? The first step is going to be to flip the second fraction over and multiply. So it becomes x plus 1 over x plus 2 times x minus 4 over x plus 3. There's nothing to cancel, so all I do is multiply, and our final answer is going to be x squared minus 3x minus 4 all over x squared plus 5x plus 6. So the steps we do when we're working with algebraic fractions are really exactly what you did back in grade school. If you've got addition and subtraction, you look for a common denominator, you add and subtract the numerator of the fractions, the top, and you leave the bottom alone. When you have multiplication problems, you first of all see if there's anything that'll cancel. You multiply across the top, you multiply across the bottom, and you're done. And when you've got a division problem, you flip over the second fraction and you multiply. Multiply by the reciprocal of that second fraction. So that's it for this week. You will have a quiz this week that involves both last week's and this week's materials, both functions and fractions. And that quiz will be a little bit different from what we've usually done. Instead of being done online, this one, it's a PDF that you can find in your computer. And what you need to do is do the problems in writing. You can print out the sheet, that's great. Otherwise, you can just do it on a piece of notebook paper. What you want to do then is to like take a picture of your work and then send it to me, and that's going to be what you do for your quiz this week. And in all of my videos this week, I'm actually putting a picture that you might remember seeing on my bulletin board back at the beginning of the year, back before we ever thought about pandemics. But it would be kind of nice to have a pandemic that was a good thing, and, if we were all kind to each other, that just might happen. So keep that in mind, have a good week, and we will talk to you again later.